Hello everyone, welcome to my channel. Today we'll discuss about differential equation. So there are few techniques to solve differential equations. So we'll mainly discuss about the techniques. So how to solve differential equations. So what are the first technique we should know is called separation. Okay, separation. So what is the first one? This is a very easy one. Separation means you have to separate the variables. Okay, so how to solve this? Suppose I am giving one equation, dy dx equals to y tan x. So this is a very easy one. First one, this method is called separation. So there are four technique we should know. So first one is separation, second one will be substitution, then homogeneous, and number four will be linear differential equation. So for up to class 12, we should know these four techniques to solve differential equation. And in the higher class, there are several techniques more to solve differential equation. But up to this, up to 12, class 12, we should know four techniques only. So first technique is called separation. I call it separation. Now what is separation? Separation means you have to separate this variable. Look, there are two variables y and x. So you have to separate such a way that y and dy are together and x and dx are together, like this. Okay, so you have to separate two variables x and y such a way that dy contains y terms and dx contains x terms. So you can see here, there is my dy, here it is my dy, and here it is y. Now if I replace, I can write like this, dy by, if this y come here and dx go there, that will become dy by y equals to tan x dx, like this. Okay, and now integration of, now integrate both sides. So what we need to do first? First we have to separate according to the variable. So if there is y, we have to separate with dy, and if there is any x, we have to separate with dx, like this. Okay, so dy by y equals to tan x dx. Now separation done. After this we have to do the integration. So what is the integration of 1 by y? That will be log mod y equals to, now this one tan x. Now how to find the integration of tan x? So in differential equation, integration is very important. So how to find the integration of tan x? There is a formula also, but how to find? Tan x means sin x by cos x. Okay, so now here, look at here. Now look at the denominator here, cos x. Now we know the derivative of cos x is what? Derivative of cos x is minus sin x, but in the numerator we can see there is a sin x. So I am just putting a minus here, and outside 1 minus. So minus minus is plus. Now look at it properly. Derivative of cos x is coming minus sin x. Now if the derivative of the denominator is coming the numerator, then the integration will be log mod denominator, that one. Remember this one. Okay, if the derivative of the denominator is the numerator, then the answer will be log mod the denominator. So here you can see derivative of cos x is minus sin x, that means the integration will be log mod cos x, or we can write like this also, log mod sec x. So this is the formula of integration of tan x. So integration of tan x will be what? Log mod, we can take sec x, or we can take minus cos, like this, anything. So I'm just writing log mod sec x. Now after integration I need a constant. Now this constant we can choose anything according to the situations. Now look at here, there are log, so I can take here log c. Okay, one can take only c also, but according to the situation, see there is log, so I am choosing here log c. Now we have to use the property of the log. Now what is the property? Now there is log a, this is log a, and this is the log b. Now log a plus log b, what is the formula? Log ab. That means that become log mod y equals to log mod c into sec x, like this. Okay, so log mod y equals to log c into sec x. Now log both side, so that will be mod y equals to mod c sec x. Okay, like this. So that will be the answer. If I square both sides, that will become y square equals to c square sec square x. So this is my differential equation. This is the differential equation. So this is a very easy one. So first one is separation. So what is separation? We have to separate the variables according their variable. Okay, look at here. So that means if there is a y, we have to separate y with dy, and if there is x, we have to separate with x, like this, and after that you have to just integrate that one. So this is the separation, first one, first technique. So there are four technique. First technique done. So this is called separation. Now the next one, the next technique is called number 2. Next technique is called substitution. Okay, substitution. First we'll discuss all the topics, okay, all the technique. Now after that we'll solve several problems, some important problem. Okay, so next one is substitution. Now what is substitution? That means you have to substitute something, because now look at here. Suppose I am giving one problem, dy dx equals to root x plus y plus 1, this one. Now I have to solve this one, dy dx equals to root x plus y plus 1. Now here you try to separate this one. Okay, it will not separate, because look, there is a problem. What is the problem here? It is root over x plus y plus 1, like this. Now if I separate dy with y, dx is x, it is not possible. Try to separate this one, you will not be able to separate. So here what to do here? Now what is the problem here? This one, this part, x plus y plus 1, root under of this is the problem. Okay, so here I need to substitute. What to substitute? I am taking x plus y plus 1 equals to z square. Y square, because there is a square root, so just for that I am taking it is z square. Done. Now this is called the substitute. Okay, why I am taking the substitute? Because we know now from here it is impossible to separate the variable. Okay, so that's why I'm just taking the substitution. So here x plus y plus 1, I am taking z square. Now differentiate this one with respect to x. So derivative of x with respect to x will be 1, then it will be dy dx, and derivative of y 1 will be 0, and next will be 2z dz dx, like this. Okay, so from here what will be dy dx? So my dy dx will be like this, 2z dz dx minus 1. Done. So this is the dy dx. Now we have to just put the value here. Suppose this is equation 1, so we have to put the values here, equation 1. Okay, so from 1, now from 1 here, what is dy dx? So here we get the value of dy dx here. So what is the value? 2z dz dx minus 1. So here we can put 2z dz dx minus 1 equals to root over of, now look at here, x plus y plus 1 is there. Now what is the value of x plus y plus 1? That is z square. So that is root under of z square, like this. Now root under of z square, that will become z. So that will be dz dx, and there is a minus 1. If it goes there, it will become plus 1. So plus 1 plus z, like this. Done. Now what we need to do? So now every case, every problem, after at the end of that we have to do the separations. Now here separation is possible. Now how to separate? Look, there are two variables. One is z, one is x. Now we have to separate such a way that dz contains z terms and dx contains x terms only. So here you can see 1 plus z, so that 1 plus z will come here, that will become like this, 2z 1 plus z dz, and dx will go there, that will become dx, like this. Okay, at the end of the step you have to do the separation. Now separation done. Dz contains z terms and dx contains x term. Since there is no x, so just we can see dx is alone here, so that means there is only 1 is there, so 1 dx, like this. Now separation done. Now we have to integrate both side. Now just I am integrating both side. Now again I am telling that one, for differential equation you should know how to solve integration, because for differential equation it is very important to know how to solve integrations. Okay, so now next one, this one, how to solve this one, 2z by 1 plus z. Now how to solve? 2 is a constant here, so 2 will get out of the integration, that will become z by 1 plus z dz equals to, now here you can see 1 dx. Now so integration 1 dx, I'm just writing like this. Now how to solve this integration? So look at this, the power is here 1 and the highest power in the numerator denominator is also 1. Now if the power is same, okay, remember this one, if the power is same, we have to arrange the numerator as denominator. That means look at here, what is the denominator? 1 plus z, so, and the numerator is z, so we have to arrange the numerator like denominator. That means 1 plus z, I'm just writing 1 plus z here, okay, and minus 1. Why minus 1? Because if 1 and 1 cancel out, it will become z, so I'm just writing z as the form of the numerator, so I'm writing 1 plus z minus 1 like this, and integration of 1 dx. Now if I separate this one, what will happen? 1 plus z by 1 plus z, that will become 1 dz minus, and 1 by 1 plus z dz like this, okay, and integration of 1 dx, okay, like this. Now it is very easy. 1 integration of 1, what will be the integration of 1 with respect to z? That will become z minus, now 1 by 1 plus z, that will become log mod 1 plus z like this equals to, and here also you can see integration of 1 dx, so it can be taken, integration of 1 dx will be x, and at the end you have to put a constant, so I'm just taking here c, okay, so depending on the situation you can take the constant term, so here I'm taking the constant term as c. Now we can see there is a z, so what is z? From here we can see what is the value of z. The value of z is root over of x plus y plus 1, so here it will be root over of x plus y plus 1 minus log mod 1 plus z. Z means again root over of x plus y plus 1 like this, and then it will be x plus c. Done. So this is the way to solve this type of things, okay. So this is the type 2, that is substitution. So first one was separation and next one is substitution. In substitution you have to substitute one thing, okay. So here I am just substituting x plus y plus 1 equals to z square. Why you have to use the substitution? Because it is impossible here to solve these equations, okay. It is impossible to separate, okay. So first, whenever the equation is given, you have to check it is possible to separate or not. If it is not possible to separate, so you have to go to the next step. What is the next step? Substitution. So here you can see x plus y plus 1, I'm just taking z square. Why it is square? Because there is a square root like this, and then you get dy dx. After that we're just putting the value in the equation 1, and then after this separation. Next, at the end, in every cases you have to do the separation, so just separation, and at the end this is my answer, okay, like this. So that will be the answer. So this is the way to solve this one, substitution, okay. Now question number 3, technique number 3. What is the technique number 3? So at first we'll solve 4 techniques, and at the end of the day we'll solve the problems, okay, miscellaneous problems, okay. So number 3, type 3. What is type 3? That is homogeneous problem, okay. Now what is homogeneous? How to know one thing is homogeneous or not? Suppose there is a function, okay, fxy. The function is like this, x plus y, and here x minus y. Now look at here, what is the highest power here? 1 1. Now if I add, the power will remain unchanged. That means overall power of the numerator is 1, and here also you can see the power is here 1 1. That means it is also 1. So the power of the numerator and power of the denominator is same. That means it is a homogeneous function. Again, suppose a function is like this, xy by x square plus y square. Now what is here? You can see the power is 1, here also the power is 1, but there is a product. Now if there is a product, the power will increase. That means it will be added, 1 plus 1, that means 2, and here the power is 2, here the power is 2, but it is a addition. That means there will be unchanged. That means the power, whole power will be 2. Now we can see the numerator and the denominator has the same power. Now if they contain the same power, that means it is a homogeneous. Okay, so whenever this type of thing came, first check it is a homogeneous or not. Okay, so this is the way to check it is a homogeneous or not. So we'll solve a problem what to do when there is a homogeneous. So if there is a homogeneous, we have to take y equals to vx or x equals to vy. So this is also according to the situation. I'll explain when to take y equals to vx and when to take x equals to vi, like this. Okay, so whenever homogeneous function is there, we have to take y equals to vx, like this. So we'll solve a problem. So now next we'll solve question number 3. Okay, now question is like this: 2xy dx plus x square plus 2y square dy equals to 0. Okay, so this is a problem. 2xy dx equals to x square plus 2y square dy. Now how to solve this? First we have to arrange such a way to find dy dx. Okay, now from this one, if the equation is given, first find dy dx. This is the first thing you have to do. So now from here, how to find dy dx? Just arrange properly. That will become 2xy dx. Now it will become minus of x square plus 2y square dy, like this. Now what will be dy dx? If dy dx will be, dx will come here and it will come here. So that will become 2xy, and there is a minus will come here also, x square plus 2y square, and that will be dy dx. Now this is the dy dx. Okay, so this is the dy dx. Now check properly. Now again, if you try to separate, first again I am just telling this, a equation is given, try to separate the variables if it is possible. Now if you see properly, now it is not possible to separate. That means it is impossible to separate such a way that dy contains y and dx contains x. So it is not possible. That's why you have to use another technique. Okay, so whenever an equation is given, first try to separate. If it is not possible, then you have to use another technique. Now here, now what will be the technique here? Now look at here, the power. Here the power is 1, here the power is 1. The product, that means the overall power is here 2. Now here the power is 2, here the power is 2. Now since it is add, it will be 2 only. That means the numerator power is 2 and the denominator has power 2. Both has the same power. That means it is a homogeneous function. Okay, so whenever the powers are same, that means it is a homogeneous function. So the function look like this: dy dx equals to minus 2xy by x square plus 2y square. Okay, so this is the way to check this is a homogeneous or not. Now you can see this is a homogeneous function because the numerator has the power 2 and the denominator has the power 2 here. Now what to do whenever this is a homogeneous function? We have to let y equals to vx, like this. Okay, so whenever there is a homogeneous function, take y equals to vx. Now next step will be dy dx. That means we have to differentiate with respect to x. So that will be dy dx. Now this is a uv formula, v into derivative of x, that is 1, plus x into derivative of v, that means dv dx, like this. Okay, that means dy dx equals to v plus x dv dx. Now if I put here, now we have to put the values here. Okay, so that means it will become, so dy dx, that means v plus x dv dx, that is the left hand side, equals to, now look at the right hand side here, that is 2xy. Okay, that means minus 2x into y. What is y here? Vx, by x square plus, now x square plus 2y square, that means 2 into y square means vx whole square, like this. So the numerator will become like this, 2vx square, and the denominator is x square plus 2v square x square, like this. Now from the denominator we can take x square, so it will look like this. So that will be v plus x dv dx equals to, now it is minus 2v x square divided by, now look at it, this is minus 2v x square divided by, if I take x square here, that will become 1 plus v, like this. Okay, that will become 1 plus, sorry, 2v square, 1 plus 2v square, like this. Now x square will be cancelled out. So again, x dv dx. Okay, just simplify, just simplification. Okay, now v will go there, that means minus 2v by 1 plus 2v square minus v, like this. Then only simplification. Now do the LCM, 1 plus 2v square, that will become minus 2v minus v minus 2v cube, like this. So here minus 2v minus v, that means minus 3v. So that will be x dv dx equals to, and it will be minus 3v, done, minus 2v cube, minus 2v cube by 1 plus, and that is what, that is 2v square. Okay, 2v square. Now done, up to this, done. Now next thing, again the same thing, we have to separate the variables. That means here there are two variables here. V, one variable is v, another variable is x. Now we have to separate such a way that dv contains v terms and dx contains x terms. So that means it will become like this, it will be like this, 1 plus 2v square by, now here 3v, if I take the minus, I'm just taking the minus out, so that will become 3b plus 2v cube, like this. Okay, and here it is dx, okay, dx by x, like this. Okay, and here there will be a dv. Done. So first, and here you have to separate such a way that dv contains v terms and dx contain x term. So separation done. Now we have to integrate both sides. Now on the right hand side, it is very easy, 1 by x, the integration will be log mod x. Now what will be the left hand side integration? So it looks a complicated figure. Now how to solve this one? Now look at properly here, the denominator, look at the denominator. What is given? 3v, I'm just writing here the denominator, only denominator I'm just writing 3v plus 2v cube. Now if I differentiate this one with respect to v, what will happen? The differentiation will be 3, because the derivative of v with respect to v will be 1, plus, now it will be what, 6v square. Now if I take 3 here, what will come? 2 plus 1 plus 2v square, like this. Now look at here properly, this one. Okay, this is the differentiation of this one. So differentiation of 3v plus 2v cube is coming like this, 3 into 1 plus 2v square. Now look at here the denominator, numerator, look at the denominator, numerator, it is 1 plus 2v square. Only thing is missing is the 3. So what we'll do, we'll just take 1 by 3 here and multiply 3 here. That means 3 into 1 plus 2v square by 3v plus 2v cube dv equals to integration of dx by x, like this. Okay, now from here we can see the derivative of the denominator. What is the derivative? This one, derivative of this one is coming the numerator. Look at here, derivative of 3v plus 2v cube is what? 3 into 1 plus 2v square. That means derivative of the denominator is coming the numerator. Now I have given the formula, whenever the derivative of denominator is coming the numerator, the integration will be log mod the denominator, log mod denominator. What is the denominator here? 3v plus 2v cube, like this. Okay, equals to 1 by x, that will be log mod x. And again the now you have to take the constant, you can take the constant as c also. Okay, so take log c, like this. So that will be log mod 3v plus 2v cube whole to the power minus 1 by 3, and so on, and it will be log cx. Again log cancel out, that will be 3v, okay, 3v plus 2v cube whole to the power minus 1 by 3, and that will be c mod x. Now what is the value of, you know the value of v? What is the value of b? Here we have taken the v, here we have taken, here we have taken y equals to vx. Okay, so from here you can see what is the value of v. The value of v is y by x. So from here just put the value here and simplify, you'll get the answer. Okay, 3y by x plus 2y cube by x cube whole to the power minus 1 by 3. Okay, and c mod x, like this. Now we have to just simplify and that will be the answer. Okay, so this is the way to solve type 3. So type 3 is the homogeneous. So whenever the power of the numerator and denominator is same, just apply this one. Okay, homogeneous, technique number 3. Now next one is technique number 4, type 4, that is differential linear equation. Okay, linear differential equation, this is very important one. Linear differential equation. So this is the last one. So there are 4 techniques, this is the last technique, linear differential equation. Only remember this 4, that will be enough. Okay, so first technique was separation, second was substitution, third was homogeneous, and the last one is linear differential equation. Now what is linear differential equation? Whenever an differential equation is of the form like this, dy dx plus py equals to q, or dx dy plus px equals to q, then this is called the differential equation, linear differential equation. Okay, whenever a differential equation is of the form this one, this is called the linear differential equation. Okay, look, y is here, y is here, in one line is there, y and y in one line, so this is called linear differential equation. LD means linear differential equation in y, this is called linear differential equation in y, and this one is called linear differential equation in x. Okay, so this is called linear differential equation. So differential equation of the form this, then you have to apply this one, linear differential equation. Now we'll solve one problem of this one. Okay, so question number 4. Now next one, the question is like this, x, it is written like this, x dy dx plus 2y equals to x cos x. This is given. Okay, x cos x. Now this one, look here, x dy dx. Now what is the first thing we have to do? Look at here, dy dx, the coefficient is here 1. So whatever we did coefficient here, dy dx coefficient, we have to make it 1. So how to make it 1? There is a x, so we will divide it by x both side. Then what will happen if I divided both side by x? That means x cancel out. Here it will be 2 y by x, like this, and here if I divide x cos x by x, that will be x cancel out. That means it is coming like this, dy dx plus 2 by x into y equals to cos x, like this. Okay, so dy dx plus 2 by x into y cos x, this is the linear differential equation in y. Now this is similar as, this one is similar as dy dx plus py equals to q. Look at properly, this one and this one is same. Okay, so this one, that means this equation is a linear differential equation in y. Now whenever there is a linear differential equation, how to solve this? We have to first find integrating factor. Okay, you have to find integrating factor. What will be the integrating factor? E to the power integration p dx. Okay, if it is a linear differential equation in y, then the integrating factor will be e to the power p dx. Okay, remember this one. If it is linear differential equation in y, then the integrating factor will be e to the power integration of p dx. Okay, but if it is in x, it is a linear differential equation in x, then the integrating factor will be slightly changed. That means integrating factor will be e to the power p dy. Okay, just remember this one. Okay, whenever it is a linear differential equation in y, the integrating factor will be e to the power p dx opposite, and whenever it is of x, it will be p dy. So this is a linear differential equation in y, so it will be e to the power p dx. Now e to the power p. Now look at here, compare. So if I compare properly, look at here, this is the p here, so p here will be 2 by x, so that will be 2 by x dx, like this. So e to the power 2. Now 1 by x dx. So what is the integration of 1 by x? The integration is log mod x. Now if 2 goes there, it will become log x square, like this. Okay, and e to the power log is there, then it will be x square only. Okay, this is the property. The property is like this: a to the power log, remember this one only, e to the power log, suppose here it is x. Now if e and log are both together, the answer will be only x. Okay, remember this one. So it will be e to the power log x square, the answer will be x square. So the integrating factor is x square here. Okay, so this is the integrating factor. So whenever it is a linear differential equation, you have to first find the integrating factor. So integrating factor, you have got the integrating factor, done. Now what is the next step? Whatever with the integrating factor, you have to multiply it with equation 1. Okay, so my integrating factor is x square, so you have to multiply. Now multiply integrating factor with 1. That means the integrating factor you have to multiply here. Okay, you have to multiply integrating factor in equation 1. That becomes, then it will become like this. If I multiply x square dy dx plus, okay, dy dx plus 2 by x y equals to, here it will be x square cos x, like this. Okay, x square cos x, like this, done. So this is, you have to multiply. Now this one is a very important step. What will be the left hand side? So left hand side, how to write? D dx, right? D dx, because it is d and dx is there, so d dx. Now here what to write? This is a linear equation, linear differential equation of y. That's why you have to write y here, into the integrating factor. What is the integrating factor here? X square. Okay, so here again I am explaining what to write. D dx, because here it is written d dx, so here I am writing d dx. Okay, if it was d dy, you have to write d dy, done. Now next, first here you have to write the linear differential equation. We know this is a linear differential equation in y, that's why you have written y here. Okay, into the integrating factor. Now here what is the integrating factor? The integrating factor is x square, so y into x square. Left hand side will be like this, you have to write, and right hand side will be same, x square cos x. Okay, now why I am writing like this, y into x square? Because if this is a product form, if I use the product form of derivative, it will look like this only. Okay, it will look like this only, so that's one you have to remember. So you have to write like this, d dx into whatever with the linear differential equation. This is a linear differential equation y, so here you have to write y into the integrating factor. What is the integrating factor here? The integrating factor is here x square, so y into x square, like this. Now this dx will go there. Okay, so that will become dy x square equals to x square cos x dx, like this. Okay, now integrate both side. Now you have to integrate both side, done. Now what will be the integration of this one? So remember again, you have to remember one thing, integration of dx is what? X. Integration of dy is what? Y. That means integration of d y x square, it will be y x square only. Okay, because integration of dx, the answer is x. Integration of dy, the answer is y. Integration of d of this one will be answer of this one only. Okay, so here integration of dy x square, the answer will be y x square, like this, equals to. Now on the right hand side there is a integration. What is the integration? X square cos x dx. Okay, now x square cos x dx, how to integrate? This is a uv formula. bypass. Okay, so what to take u and what to take v. So this is my u, so only bypass, integration bypass, this is the v. Now use the property of the bypass. Okay, so what will be the bypass form? X square integration of cos x dx minus integration of d dx x square integration of cos x dx, like this, and dx. Okay, only bypass, so that will be x square integration of cos x is sin x minus, now x square, derivative of x square is here 2x, and cos x integration is sin x dx, like this. So that will be yx square sin x. Now again, uh, 2 is a constant, 2 will become here. Okay, done. Now again you can see this is the uv form. Okay, again x sin x, so u, that will be u, and this will be my v. Now again use that formula, same formula, x integration of sin x bypass, okay, dx minus integration of d dx of x integration of sin x dx. Okay, and at the end there will be a bracket dx, only bypass. Okay, so this is the bypass form only. Now it will be y x square sin x minus 2 into x sin x, integration of sin x is minus cos x, so minus x cos x minus integration of derivative of x is 1, and integration of sin x is minus cos x, that will be plus integration of cos x dx. Done. Now it is very easy, it will be yx square equals to x square sin x minus minus plus 2x cos x minus 2 into integration of cos x is sin x plus at the end c. Okay, so that will be my answer. So this is the way to solve linear differential equation. So this is the 4 techniques we should know. Okay, first one is called separation, first one is the separation, second one is the substitution, third one is the homogeneous, and fourth one is the linear differential equation. Okay, these 4 technique you have to solve this type of differential equation. Okay, just remember this one. Okay, so according to the question, okay, you have to solve. Suppose the question, first if the question is given, okay, one thing you have to remember, depend marks is also important. If the question is given in the mcq, if the question is given in the mcq, or it is a 2 marks question, so the chances are it is of the form separation or substitution. Okay, chances are 90% chances are there that will be separation. Okay, 90 substitution or separation. But if the marks of the question is around 4 or something, okay, more than 3 or more than 4 like this, then there are chances of linear differential equation or homogeneous. Okay, homogeneous, like this. Those are the chances, 90% chance, not necessarily that will be the case, but 90% of cases, if the marks are of there is a 2 marks question or 1 marks question, then the chances are that will be a separation or substitution, anyone. And if the question contains the marks 4 or more than 4 or 3 like this, then there is a chance this will be a linear differential equation or homogeneous. Okay, so marks is also important, so depending on that you have to check. Okay, first if the question is given, first you have to try if it is possible to separate or not. If it not possible, then go to the next step. Next step is what? Substitution. If it is possible to substitute that one. Done. Now if it is not possible to substitute, now next step is what? Homogeneous. In homogeneous, how can you know this is a homogeneous or not? First write like this, dy dx equals to something by something form. Okay, dy dx equals to something. Okay, now if the this one, okay, the power of the numerator and the power of the denominator, degree of the numerator and degree of the denominator are coming same, that means it is a homogeneous. And for homogeneous you have to do y equals to vx, like this. Okay, and if it is not homogeneous, then go to the linear differential equation. Now this is the linear differential equation, this format. Okay, if the equation is of the format this dy dx plus py equals to q, that means this is a linear differential equation. And in linear differential equation you have to first find the integrating factor, and then, so what are the step? First, this will be the linear differential equation, dy dx equals to py equals to q, or it can be dx dy plus px equals to q. Second step will be you have to find the integrating factor. After that you have to multiply, okay, multiply the integrating factor, whatever be the integrating factor you have to multiply both sides, then again integrating and so on, you'll get the answer. Okay, like this. So those are the techniques we should know for differential equation, and in the next video we'll solve several problems of this type of cases. Okay, so here only I have solved one each question for each technique. Okay, for first one separation, then substitution, and so on, like this. Okay, and in next video we'll solve the problems of this separation miscellaneous problem of this one. Thank you for today.